Okay, hello, and welcome to hopefully the first of many Dartwatch webcasts. In this session, we'll be chatting to Dart developer experts Adam Singer and Kevin Moore about their use of Chrome packaged apps. Uh, Adam, are you there?
Yep. Hey, what's going on?
Hi. And Kevin?
Hello from North Carolina.
Hi. Right, we're going to jump straight in and start talking to Adam about the benefits of Chrome packaged apps and how you can use them in your Dart app and some of the challenges that you might find when you're coding. Adam.
Yeah. So I've been I've been looking into the Chrome packaged apps just for fun to see how complicated and what's involved to create packaged apps in Chrome with Dart. Some of the benefits, the reason why I find it very attractive because it's a single platform to program against, and I look at the browser as the platform, and have a application inside of Chrome is like a nice unified platform because Chrome is such a strong web browser. The stable and continuous release cycle of Chrome is always beneficial, especially when you're programming with something like Dart and you're on the bleeding edge. You just kind of want to know that the platform behind it is definitely stable and you're not dealing with weird, odd bugs of browsers. And the Chrome Store, obviously, because at some point we all want to make money on creating our applications, and Chrome Stores provides us a medium to charge or to, release to a larger audience than just having some web page randomly somewhere.
Oh, that's great. And so, I guess one of the good things about the Chrome packaged apps is that as well as appearing within your browser, it acts almost as though it's a native application, sort of outside of the browser.
Yeah, so the packaged apps API provides some lower level interfaces that you definitely wouldn't get within a normal web browser, such as Bluetooth, file system, not raw sockets, but TCP, UDP sockets, serial port communication, USB communications. It really provides an additional rich interface to just a plain browser app, but a plain web application. It really gives you a sandbox, low-level access to devices and other things in your computer.
That's cool. So if you want to use any of those extra APIs, sort of file system or Bluetooth, do you need to explicitly request permission from Chrome to allow access to that?
Yeah, so with the Chrome packaged apps, you need to have a certain type of structure for your released application. And in that structure, you need to have a manifest file. And in the manifest file, you'll explicitly declare what permissions and what APIs you want for your application and what permissions that API is going to use. And for one example, it would be like sockets. You can tell your application that it's only allowed to communicate to this domain through these certain ports, and that's all that application provides. So it helps ensure the security of the application and security of the user of the application by restricting, only whitelisting what what permissions that API should be using. So
That's cool.
Uh-huh.
So with some of the APIs, not everything's available in the Chrome packaged app. Not all the APIs that you usually have in Chrome, some of them are restricted to packaged applications. Can you detail some of those ones?
Yeah, so a lot of the stuff is the same except for a few things. One of the major differences you're going to notice is file system. File system is different than the Chrome web browser. You have to use a different API. It kind of acts very similar, so it shouldn't be too difficult to get around, but it's definitely a different API that you're going to call. You're going to call Chrome.filesystem instead of just the regular file system API in
Cool.
HTML5.
But the fact that you can actually access the file system, you can access any file in the file system through a Chrome packaged app?
Yeah, you can access the local user's file system, and you can access the persistent file system in the web browser. So you get both file systems.
That's pretty cool. Okay, so you're creating a Chrome.Dart library, which is a set of wrapper APIs that fit around the Chrome APIs that are available to JavaScript?
Yeah, so the goal of that API is right now, if you want to write Dart code and deploy it as a Chrome packaged app, you must compile it to JavaScript. One of the requirements is to compile it to JavaScript first, for the obvious reason that the Dart VM doesn't exist in the browser, in Chrome browser yet, or Chrome packaged apps yet. So what we want to provide is an easier and simpler API to use that gives you full access to those APIs and gives you additional benefit of having some state in your objects that you use. So a lot of the Chrome APIs are very stateless callback, very JavaScript-centric APIs. Very much like a lot of the APIs with Google, they just want to give you the API, you call it, and you kind of manage within your application's context what's going on. And then the Chrome.Dart project, we want to cover all the APIs and provide better wrapper objects for those APIs. So you can just new up a new file system and you use it like you would expect to use a file system without too much fancy callbacks or futures or managing the handlers that you need for whatever, for socket, like managing, I know this, I have 10 handlers for my sockets or 10 socket IDs. Let the object that's in Chrome.Dart manage that for you instead of your application having to track it.
That's pretty awesome. Have you got examples that you can show us running at the moment?
Yeah, so far we've covered Chrome.Serial and Chrome.Socket APIs. And if I just share my screen with you, I can show you an example of, and we also have a test harness going. So as we're covering new APIs, we just write tests for it. Sometimes they're a little bit harder to test, but it's definitely something you want to test. So let me just bring up my screen real quick. So when you're first creating a Chrome packaged app with Dart, you're going to need a modified version of the Dart.js loader. And the reason you need a modified version is because the Dart.js loader has some legacy code that depends on local storage. And one of those differences, as I mentioned earlier, is local storage is not really available in a Chrome packaged app. You need to use the file system API. So if you head on over to our GitHub repository, you can find that we've already provided Dart.js with a modified local storage. Another requirement of the Chrome packaged apps is the content security policy, and everything really needs to be local to the app. You're not allowed to suck things in from other websites or other URLs outside of what you've specified. So I found it easier working with the Chrome package apps to make sure that everything is within the application, and there's no unsafe evals are not allowed either. So you can't just load up JavaScript and eval it on the fly. You have to have it all kind of contained in your application. Another not requirement, but if you actually want to communicate with APIs, if you just want to create a Dart create an application purely in Dart and compile to JavaScript that doesn't use the Chrome APIs, you don't need the JS Interop project. And JS Interop is a Dart application that lets you communicate with JavaScript APIs. But if you just create just a pure JavaScript application with no communications to the Chrome packaged apps APIs, you can deploy even easier. If you do, on the other hand, you need the Dart Interop JS file that's provided with the JS Interop application, and that you copy from the library. Let me see where that is.
That's cool. Adam, while you do that, could you make your font a bit bigger in your Dart editor?
Sure.
That's great.
Hopefully that's...
Oh, that's a bit better. Great.
Let's see. Select font. See if we go a little bit larger. Okay. So You want to make sure that that Dart underscore interop.js is also within your application. You need to have the main.js loader and your manifest file, and then your Dart application. And as you can see of this manifest file, we use the version 2, which is the latest version for the Chrome packaged apps. And we require that the permissions are serial for this particular application. So for this application, I'm going to communicate to ADK 2012, just a simple echo to the serial port, and then the ADK, the ADK board will then echo the output back to me. And then when you specify your app, you specify the script main.js. And main.js is where you would load your actual window for the application. This is kind of the background script that does the loading of your Chrome application. So as you can see here in JavaScript, we create a Chrome app window, or a Chrome app window create, and then we call the HTML file that contains our Dart application that has the generated JavaScript. So if we head over to the HTML file, we can see the 3 scripts that we need loaded in this order is the Dart.js file, Dart underscore interop, and the Chrome serial example Dart.js file. And that serial example is the actual example of the program. If we head over to that code, the JavaScript code, we can see it's very simple. We include the Chrome.dart package. We go and we find our serial ports that we have available, and we add them to a drop-down. When we want to open up the serial port, we just call serial open. We new up a new serial open, and then we can read from the serial device. And then here, on event ping data, we write the stuff that's in the input buffer app. So if we just launch this application, you can kind of see what I'm talking about. So here we have a very simple Dart application. We have a drop-down list of all my serial devices. So we'll pick this USB serial, which contains the ADK 2012 board. We'll open up that. We have an instance. You can see in the console output that an instance has been opened of the serial device. And when we ping it, we'll say hi from Chrome app, and then Pong will just respond with the output of hi from Chrome app back to me. So it's very basic data that goes back and forth. So we change that up, and that's all going over the serial device to the ADK board. And another example is our test harness, which our test harness ensures that the wrappers that we're creating actually run correctly. And I definitely would suggest making sure you have test harnesses for your Chrome application, because the compiling to Dart, to JavaScript, and then loading into a Chrome app is still, new territory, and stuff will definitely break or change or work funky. But we were able to get a good test harness going, which ensures that our APIs kind of fluidly work or continuously work. And you can see we got 3 APIs. So we have Chrome.runtime, Chrome.serial, and Chrome.socket.
Cool. And so that's about, what, 15% of the way through the Chrome APIs?
Yeah, there's a lot of them. I think there's like 20 or so.
Cool.
Yeah.
What I'll do, I'll share the GitHub repository for this on the blog afterwards.
Oh, wonderful.
That's pretty awesome. Do you have the ADK board that you're talking about? What's that board?
Oh, okay. The ADK was a board they gave out during Google I/O last year, and it's a nice little Arduino board with a bunch of sensors, LEDs, NFC, Bluetooth. And the reason I even stumbled upon Chrome packaged apps to begin with, I went to a Chrome hackathon in Mountain View, and I brought my ADK, and I was hoping that I can work against the Bluetooth API in Dart and do like a Bluetooth scanner or something in Dart as an application. And what I found out is after a lot of hacking, I was using the Chrome extensions APIs instead of the Chrome apps APIs, which is, it's not a clear distinction yet, but you can tell through the URL of the documentation you're reading. If you're doing Chrome packaged apps, you want to make sure that you're at the apps API directory and not the extensions API directory, because the APIs are actually a little bit different. The extensions directory has a lot of experimental APIs, where the app directory has those experimental APIs in the root Chrome namespace. And the other thing I found out, which is the things that you kind of run into with doing Chrome packaged apps, is the Bluetooth API is supported on Chrome OS, but is not supported on Mac OS. So unless you really know or you're in the loop, I didn't know at the time, as I was doing this whole example, and by the time I started to call the Bluetooth API, it was like, no, it's not available on Mac. So then, then I started using the serial port, and here we are today.
Ah, cool. That's great. Thank you very much for that, Adam.
Mm-hmm.
I'd like to jump over to Kevin now, if he's available. Hi, Kevin.
I'm still here, wasting time playing a game.
That's cool. Would you be playing Pop Pop Win by any chance?
I've managed to pretty much suck all the fun out of that game. It's when you write a game, I find you spend a lot of time playing it just to make sure you hit all the edge cases. So I think I've extracted all the fun I can out of Pop Pop Win.
Cool. Okay, so you converted your Pop Pop Win game into a Dart packaged app. So Pop Pop Win, for those who haven't seen it, is a sort of Minesweeper clone, and it runs as a Chrome app in the web browser, just as a bog standard Dart Chrome app, just as a bog standard Dart app. But you've also converted it to a packaged app, which sort of gives it that native feel, runs without a web browser, runs sort of straight from the desktop from your application launcher. So how did you manage to convert it over? What were the challenges you faced?
Well, first I want to give kind of credit where credit's due, because Adam did the initial conversion and got it all working. And actually, I know you and Adam cannot see this, but I'm going to load up the game quick just to show people how it plays in the browser. It's loading, I swear. Okay, so here's Pop Pop Win, and you can see you can click on balloons. And forgive me, I think between Google Plus Hangout and running my screen capture, the frame rates are really slow, but without those things running, it actually looks pretty good. So this is the game, and I was like, well, it'd be fun if this was a packaged app. And Adam obviously has done a bunch of work getting the packaged app set of functionality working. So he actually did an initial cut getting packaged apps, getting Pop Pop Win working as a packaged app. And he kind of renamed things and changed a few things around to get it working, and it worked really nice. And of course, the problem was I would still like to keep the web experience because it's hosted on the web. And so this is where I think a set of people will run into issues, because obviously the set of APIs available to a packaged app, there's some extra APIs. There's also some things that you can't use, as Adam mentioned. And so my goal was, how do you abstract out that set of things so that it's straightforward to use both, and the bulk of the source code and the assets can remain unchanged. And that just makes things a lot easier. So I'm going to switch over to my code real quick. And so what I ended up implementing was this library, and it's called Platform Target. And it's actually a very simple thing. And what it exposes is the two places where I'm using APIs in Pop Pop Win, because obviously Pop Pop Win was initially a web game. And there were basically two sets of APIs I was using that depended on things in the web. One of them was the browser version of local storage for storing high scores. And the other thing was calling out to Google Analytics to track new games played and everything else. And so obviously the initial port of the game, when we did this, we basically just stripped those things out and made it work. And my goal was, how can I make this work how can I keep things working and abstract this out? So what I did was I created this class, Platform Target, and the idea is, which platform are you targeting? Not the best name. And this is basically an abstract class. It's not implemented abstract, because if you don't call it, or if you don't pass in any parameters. It just has a very dumb implementation. So the storage is just a local map class, and track analytics, all it does is it prints something out to the console. And then what I did was I implemented this thing in something I called the platform web, which extends platform target. And what this does is it exposes out storage as window.local storage, which is what the browser uses. And then my track analytics event I implemented by actually calling the correct scoped, using the JS library to call out and call the JavaScript Google Analytics code. And that works great. And so if we actually go into the web project here, and I'll expand out the game, you'll see there's actually two files to find. There's game.dart and the web UI, and this is called by both apps, by both the web app and the packaged app. And you'll see I have a start game method that takes in this platform target class. And so you'll see that the game, the web version of the game, is very simple, and it imports the game code, the core game code, calls the start game method with the platform web instance. And so that's the one that maps everything back to how the web does things. And so you see that we index the HTML file here, and this includes the game web Dart file. Now if we jump over to look at the packaged app, so you see app underscore packaged, or app underscore package. I did that because the word package is obviously overloaded in Dart, so I didn't want to cause confusion. And you'll see we have a very similar file, but instead of game underscore web, it's game underscore app. In this context, we call just platform target. So it turns out I have yet to implement the code that supports using the packaged app local storage to do scoring, and I don't quite know how I want to target supporting analytics, or if I'm even going to support analytics in the packaged app. And so right now this calls the default implementation. And so the upside now is, so there's a couple things, and obviously as Adam mentioned, and maybe we'll do a future screencast on how hop works, but I have two compile tasks. One does my normal Dart to JS, and the other one is an app Dart to JS. And that flips the right bit to do the right compile flag. And actually, Adam, what was that compile flag again?
Unsafe evals.
And actually, if we run that, thank you, I think you'll get a dump that actually gives you the... So I'll cancel the compile just to show. So you see I'm running Dart to JS here, and I turn on, I set the bit disallow unsafe eval. And what that does is make sure that it compiles JavaScript that's compatible with the packaged app. And packaging ends up being super straightforward. Let me actually just, once everything's compiled, let me do this correctly. Drum roll. Sorry about this, just 1 second. I think my Finder windows are a little bit confused. I scaled my screen. Here we go. Then all I need to do to package the app to upload it, I can do two things. So this in the app package directory, I can either point at this with Chrome directly to add an app that's unpackaged, or I simply right-click on this directory and do compress on Mac to create a zip file, and that's what I upload to the web store.
When you upload to the Chrome Web Store, that's a fairly simple task, is it?
Yeah, it's super straightforward. I created a developer account a while ago, so I forget if there's any song and dance you have to do to register as a developer. So look into that. I don't actually know right now because I did it a long time ago. But now, once you adding a new app, uploading it, setting versions, it's all pretty straightforward. You do want to be careful about your versioning, so that every time you upload, you actually increment your version number. But that's kind of the only real big thing you need to worry about. And then obviously it asks you for screenshots and other things to kind of make it a nice experience in their search UI and kind of their details UI. So that's the story.
Another application we did at that GD event that we all attended was John Evans' Alphabet Invasion, which is the kind of cool one because the modification to bring it as a Chrome packaged app was minimal. It was removing any reference to local storage, and creating a manifest file. And that's all that was needed to take an existing web application and transform it into a Chrome packaged app. And I have an example of that fun little application right here. Let's see if that comes up. You just press any key. Actually, let's start it directly from the application. So we have this Dart alphabet invasion. Loads up. Press any key to start. And it's just a fun little app where you press keys and you try and not let the letters hit the bottom. And the whole application is based off John's framework, Reactive Dart.
Cool. That Chrome console you've got on the left-hand side of your screen, is that from the generated background page?
No, that's your basic developer console. So if you go to inspect, you can inspect the background page, and you can inspect element. So the background page will be that initial main.js that's loaded from the manifest file, and then your inspect element is your actual application. So when we see here, we can go through and see the different elements in that application.
So you actually get access to all the standard Chrome debug tools.
Yep. As
part of a Chrome packaged app.
Yep, you get the Chrome developer tools right out of the box.
And so that, I mean, what's nice about the flow here, obviously there's, a few extra steps one has to do for a packaged app. You need to compile every time. You can't run directly in Dartium, the Dart version of Chrome. But there's some simple things, like making sure that when you compile and you're developing locally, that you compile without the minify flag set, so it's easier to debug and see if you have issues in your Dart code. And then once you get everything working, recompile with minify turned on, and that gives you a nice small output. And then once you verify that, you can upload that to the Chrome Web Store.
Right, I think we're just about getting to the end of it. Adam, have you got anything else to add?
No, nothing else.
Cool. Well, thank you very much for joining this webcast. Kevin, thank you too.
My pleasure. Good night, UK.
Thank you. Good night in the US to both of you.